Good morning or good afternoon. Today we are going to be reviewing topic C and all that we have learned during this topic of Module 4. We're going to just be focused on our focus standards for this topic, and our objective is that by the end of the day you're going to have reviewed each of the skills we've learned in topic C, and you'll feel prepared for our assessment tomorrow. You'll know you're successful when you can do these things, when you can transform equations from standard form to slope-intercept form, and vice versa. When you can graph equations written in slope-intercept form, when you can compare the different rates of graphs, tables, and equations, when you can find the slope of a line two different ways, and when you can find the y-intercept of a line by solving for b. Okay? Today we're just going to alternate examples with exercises, so I'm going to show you an example, and then you're going to do an exercise that's just like it, and then I'll show you a different example for another skill, and you'll do the exercise just like that, okay? After that, we're going to set personal goals for our assessment tomorrow, and then we'll set a class goal for our assessment tomorrow, okay? As always, please make sure that your video is on and your mic is muted, that you are showing your thinking with your work. You're participating in group work and breakout rooms, should we do that. You're having appropriate conversations. You're communicating any issues with your technology. You're remaining respectful, responsible, and safe. You're completing your class jobs, okay? Also, as we go through this, keep in mind why this stuff is important for us to learn. Obviously, short term, it is super important for you because you have a test on it tomorrow, right? But in the long term, this is all very important material for just the basis of math that you're moving towards in high school. And like I said earlier in this unit, in order to be successful in high school, you have to have this stuff. But beyond high school, in order to be really successful in life, most of the time you need that high school diploma. And in order to pass your math classes, this stuff is stuff you got to know, okay? So we're going to go ahead and get started today with some examples and exercises and get to practicing for our test. All right, here is our first example. I've just written a few different things up top that I wanted to make note of. So it says we can write the equation of a line for in two different ways. We have slope-intercept form, which is y equals mx plus b. And we have standard form, which is ax plus by equals c. And you'll see these written different ways because the way that we're given information sometimes leans toward following one of these formats. So when we're giving word problems, sometimes it's easier to take that information, write it in standard form. Sometimes it's easier to take that information and write it in slope-intercept form. So that's why we have these two different formats, okay? But we can change an equation from standard form to slope-intercept form very easily just using properties of equality. So if you look over to, or down on the bottom left, we have this equation, negative 3x plus negative 12y equals 24. And this is in standard form. It is in ax plus by equals c format. And what I'm wanting to do right here is just move some things around so it follows y equals mx plus b. Well, in y equals mx plus b, the y is by itself. So I'm going to be trying to get this y by itself, right? There's a couple of things going on. Right now it's being added to a negative 3x, and it's being multiplied by negative 12. So I'm going to undo these operations. The opposite of plus negative 3x is plus positive 3x. And I add it to both sides, cancels over here, and I'm left with negative 12y's equal. How am I going to write this? Well, if I look up at my format, my mx's, so my number times an x, comes next. So I'm going to have these three x's first, and then it's plus b, so plus a single number, plus 24. Okay. All right, from there, still trying to get y by itself, it is being multiplied by negative 12, so I'm going to divide by negative 12. And if I do it on one side, I have to do it on the other side. Over here it cancels, and I'm left with y equals, and on the right side I have to divide both terms by negative 12. So I first have 3 x's divided by negative 12, and this becomes negative 3/12, but it also reduces to negative 1/4 x. Okay, and then I have 24 divided by negative 12. This will be negative 2. And you can do this stuff in your calculator. But we now are following our format y equals mx plus b. and we have changed that around to follow that format. On the right side, it says The m in our equation, y equals mx plus b, this represents our slope. We also call this our rate. Okay, so that's what the m represents. And then the b in our equation represents our y-intercept. That is where our line crosses the y-axis. It goes on to say, what is the slope and y-intercept of the line below? So what's in our m position? What's in our b position? Well, the m position, y equals mx plus b. The m position is -1/4. So our slope, or our m, equals down 1/4, -1/4. And then our y-intercept, which is our b, is 3.4. So if I were to graph this line, I would know that the slope is going down 1/4 and the y-intercept is crossing at 3.4. Okay? Hopefully this makes sense to you. You are going to do something just like this on the next slide. All right, I want you to practice on your own. You are going to transform this equation from standard form to slope-intercept form. So you want it to follow y equals mx plus b. So please try to get y by itself. And then based on that equation, I want you to tell me what's the slope, what's the y-intercept of this line. Okay, take a couple minutes to do this and then we will go over it together. All right, going over this, the first thing I'm going to do is draw a line through my sign, and I'm trying to get y by itself. Right now there's a couple of things going on beside it. It's being added to -7 x's, and it's being multiplied by 14. So I'm going to undo these operations. The first thing I want to undo is my addition. So the opposite of plus -7x is plus +7x. And I do that to both sides. Over here it cancels, and I'm left with 14 times y, or 14 y's. And over here I'm going to put my 7x's first, and my 28, or plus my 28. From there, trying to get y by itself, still it's being multiplied by 14, so I will divide by 14. And if I do it to one side, I have to do it to both sides. Cancels over here, I'm left with y equals, over here, 7 divided by 14. Well, that's the same as 1/2, right? Make sure you keep your x with it, because there was an x with that. And then I have 28 divided by 14. Well, this is 2. So I'm now following y equals mx plus b form. And I want to identify what was my m and what was my b. Well, this is in the m position, and this is in the b position. So my m is a 1/2, and my b is a 2. All right, check your work. Let me know if you have questions with this. All right, example number 2. There's 2 ways to find the slope of a line: by counting the rise over run from point to point, or by finding 2 points in the line and using the formula y2 take away y1 over x2 minus x1. I'm going to show you both ways. So the first thing you have to do, no matter what, is find your points. Got one there, got one there, there, and there. Keep in mind your points have to be directly on the crosshair. So like this right here is not a point because it's not right there. It has to be exactly where those lines cross. Okay? So I have 4 points. What I'm going to do really quickly, just to save me some time, is write out what these points are. So this point right here is at -6, 5. Let me change that up a little bit. Okay. -6, 5. This point right here is at -3, 1. Let's see. This point right here is at 0, -3. And then this point down below is at 3 on my x, -7 on my y. So I have my points. What I'm going to do from there is I'm going to count the rise over run. So I always want to start on the left side of my graph and look towards the right. Okay, so looking at the left side, the first point I see is this one right here. So I'm just going to start with this point, and I'm going to count my rise and my run to get to my next point. So my rise tells me how many am I going up or down. Well, I'm going to go down to get to the next point. I'm going down 1, 2, 3, 4. So I went down 4, so that's a -4. And then how many am I going over? And I always move to the right. I'm going over 1, 2, 3. So this is my slope, down 4 over 3. And I can check it with my next point. I can say, okay, do I go down 4? 1, 2, 3, 4. Do I go over 3? 1, 2, 3. Yep. And for my next one, do I do the same thing? Yep. Down 1, 2, 3, 4, over 1, 2, 3. So that is my slope, down 4 over 3, using rise over run. The second thing I'm going to do is I'm going to use my formula, which is y2 minus y1 over x2 minus x1. Okay? And I just need to choose 2 points. I'm going to choose, let's see, I'm going to choose these 2 points right here, just because those numbers are looking kind of simple to me. I'm going to say that this is my first point, and this is my second. So what that means is this is my x1, this is my y1, and then this is my x2, this is my y2. So I'm starting with y2, so I'm starting with a -3. So I'm doing -3 minus y1. My y1 is a 1. Okay, and then I'm doing x2. My x2 is a 0 minus x1 was a -3. And I'm just going to solve this out. On the top, I have -3 minus 1. Well, that's the same as saying -3 plus -1. So this is -4. And then on the bottom, I have 0 minus -3. Well, that's the same as saying keep, change, opposite, 0 plus 3, 3. And you'll see that that's exactly what we got up top when we just counted rise over run. So it's up to you which way you want to use to solve for slope, but you're going to practice both ways right now. All right, for this exercise, please find the slope of the line on the left by counting the rise over run. There's one point right here, and there's another point right here. So please count the rise over run. And then on the right side, please use your 2 points that they give you to calculate your slope with your formula. And then we're going to go over this in just a second. All right, for this first part right here, this is the left side of my graph, and this is the right side of my graph. And I'm looking for the point that's closer to the left to start with. So I'm going to start with this point right here, and I'm going to move to this point right here and see what's my rise, what's my run. So my rise, I'm going down. So my rise is going to be negative. I'm going down 1, 2, 3, 4, 5, 6. So I went down 6. And then I'm going to be going over. My run is over 1, 2, 3, 4. Over 4. So my rise over run for this first part is -6 over 4. And that can be reduced. It can be reduced to -3 over 2. One thing I wanted to note to you about it being reduced, that means that if I went down 3 over 2, I would actually get a point. So if I went down 1, 2, 3 over 1, 2, did I get a point? There's one right in the middle of those two. And I just wanted to do that to prove to you that our slope can be reduced, and if you can reduce it, then you've skipped a point in between, which is completely fine to do. Okay. Now let's look at our second part over here where we're using our formula. We're going to be doing y2 minus y1. So it's going to be 4 minus -8 over x2 minus x1. 0 minus -7. All right, both of these are double negative, so I can do keep, change, opposite, keep, change, opposite. And then I'm just going to do my math. 4 plus 8 is 12, and 0 plus 7 is 7. This cannot be reduced. So this is my slope, 12 over 7, which was C. Okay? And we are done here, moving on. For example 3, we're just going to be kind of interpreting graphs and equations. So for this equation, I'm going to graph it. It tells me my slope is 3, and it tells me my y-intercept, my B, is 2. So I'm going to be starting with my y-intercept. It is up 2 on this y-axis. So here's my y-axis, and it says there's going to be a point right at the number 2. So this is my point that it gives me for my y-intercept. My line is crossing right there. And then my slope is 3. Well, what does 3 mean for my rise over run? Well, if the number is 3, what's the invisible denominator? 1. So I'm going to be going up 1, right 3. So I'm going to go up 1, right 3. 1, 2, 3. And there's my second point. I went up 1 over 3. And I don't have enough room to go to another one right here because I'd be going up 1 over 1, 2. It would be like off the graph over here. But I could work backwards if I want. And instead of going up 1, I'm going to be going down 1 and left 3. 1, 2, 3. So this is the line that I will graph here based on that y-intercept and slope. Okay. All right, so I have this graph on the right, and I'm going to be writing an equation from this graph. What I'm looking for is my m and my b, my slope, and my y-intercept. It doesn't matter which one you find first. I'm going to look for my y-intercept first, which is where does it cross this y-axis? And I can see that it crosses right here at -1. So that's my b. And then I'm looking for my slope. Well, am I going up or down if I'm moving from the left to the right? So I start with my point on the left and move to the right. I'm going to go down 1, 2, over 1. So I went down 2, over 1, down 1, 2, over 1. So it's -2 over 1. That reduces to just -2. And then I can write my equation in slope-intercept form. Y equals mx plus b. Well, what is my m? -2. So it's going to be y equals -2x plus b. What's my b? -1. So this is my answer. All right? All right, you're going to do the same thing here. I do want to point out that there was a tiny mistake, but it's fine. I want you to graph this equation here, y equals 2x plus -3. So please graph that equation. And on the right side, I want you to tell me, what is this equation? What's the m? What's the b? And please write it out in y equals mx plus b format. Okay? Give you a few seconds to do that. All right, for the first one, my y-intercept is at -3, so that's what I'm going to start with. It hits this line at -3. And my slope is 2. That means my rise over my run is 2. And there's an invisible 1 over there. So I'm rising 2, and then I'm going over 1. So rising 1, 2, right 1. 1, 2, right 1. 1, 2, right 1. And it doesn't matter really how many points you have. As long as you have 2, you have a line. So check your line with my line. Okay? And then on the right side, I know that this was a little bit crazy. Our y-intercept is all the way up here. 1, 2, 3, 4, 5, 6. It's off the graph. I apologize for that. And then our slope, if we're looking at the left and moving to the right, I can see a point is right here. And then one closer to the right is right here. I'm going to be going up 1, 2, 3, over 1. So 3 over 1, this is the same as 3. So my equation is y equals mx, so it's going to be y equals 3x plus b, which is 6. So go ahead and check your work with my work here. All right, when we cannot see the y-intercept of a line, we can always use a point to solve for it. So for example, in this graph below, we do not know what is our y-intercept because if we look at this y-axis and we look at our line, it's crossing in the middle, right? It's in between 3 and 4, and I can't just guess because that's not accurate. In math, we have to be accurate. So what we're going to do is we're going to do a few things. We're going to, first of all, plot all the points that we can see on this graph, on the crosshair. So I see one right here. Going up, I see one right here. And it looks like that's it. I only have 2 points here. I'm going to go ahead and write in what those points are. So this first point is at -1 for my x, and it's at 4 for my y. And the second point is at +4 for my x, and 1 for my y. All right, so I have these 2 points. What I'm first going to do is look for my slope. It's my rise over my run. Moving from the left to the right, I'm going to be starting with this point right here and moving to this point right here, because the one on the left is over here. So I'm starting here, and I'm going to be going down 1, 2, 3. So I went down 3, so it's -3. And then I'm saying, how many am I going to go right? Well, I'm going to go right 1, 2, 3, 4, 5. So this is my slope for this line. The next thing I need to find is my y-intercept, but it's not on here, right? I have to solve for it. So instead of just looking for it, I'm going to be using my equation y equals mx plus b to solve for it. Now I already know what my m is, so it becomes y equals -3/5 x plus b. The next thing I need to do is choose a point. I'm going to be choosing 4, 1 because they're both positive. And I'm going to plug this in for my y and my x. So my y value was a 1, so this becomes 1 equals -3/5. And then my x value was a 4 plus b. And now that I only have one variable left and it's my b, I can solve for this number. So the first thing I'm going to do is multiply my -3/5 times 4. And -3/5 times 4, if I do that in my calculator, well, I have -3 on top times 4, -12, and 5 times 1, 5. Okay, and I keep everything else the same. Sorry, I said I was going to do it on my calculator, but it did not. From there, I want to get this away from my b. Right now it's being added to -12/5, so I'm going to add +12/5. Okay. Over here it cancels, and I'm just left with b. Over here, 1 plus 12/5. So I'm going to turn 12/5 into a decimal real quick. 12 over 5, same as 12 divided by 5. That is 2.4. So this is 2.4 plus 1. Well, this is 3.4. So my y-intercept is at 3.4, and it looks like that, right? It's at 3, and it's almost halfway. It's at 3.4. So now that I have my y-intercept and I have my slope, I'm going to write it in slope-intercept form. Y equals mx plus b. So what was my m? Well, my m was -3/5. Plus b, what was the b that I got? Well, my b was 3.4. So this is the equation for my line. Y equals -3/5 x plus 3.4. Okay? All right, for number 4, I want you to do the same thing. I want you to find your slope just by counting the distance between 2 points. And then I want you to choose a point. And I want you to plug it into y equals mx plus b. So you're going to be changing your m to wherever your m is, and you're going to be changing your point to whatever your y and your x is, okay? Really quickly, I'm going to do one thing for you, and that is identify some points on this line so that you can look for these numbers, okay? All right, go ahead and get started. All right, so the first thing I notice is that going from a left point to the right point, I'm going up 1 over 1, 2, 3. Up 1 over 1, 2, 3. Up 1 over 1, 2, 3. So my rise over my run is up 1 over 3. So that's my slope. I'm going to change that right here. Okay. Next, I just needed to choose a point. You could have chosen any of these points. This point was at 5, negative 1. This point was at 2, negative 2. This point was at negative 1, negative 3. And this point was at negative 4, negative 4. So it's up to you which one you chose. I'm going to choose 2, negative 2. Don't know why. Just want to choose this one. So that means my y and my x become a 2 and a negative 2. So my y is a negative 2. My x is a positive 2. Everything else in my equation stayed the same, and it wasn't much. From there, I'm going to solve for b. The first thing I want to do is 1/3 times 2. There's an invisible 1 underneath that too. So on the top, 1 times 2 is 2. On the bottom, 3 times 1 is 3. So this is what it looks like now. Next, I want to get b by itself. Right now it's being added to 2/3. So I'm going to subtract 2/3 from both sides. Over here it cancels and I'm left with b. Over here, I'm going to change negative 2/3 to a decimal real quick. And if I do this in my calculator, this becomes negative 0.66 repeating. So now I have negative 2 minus 2/3. So the same as saying negative 2 plus negative 0.66. This becomes negative 2.66 repeating. And if I look at my y-intercept, is this right at about negative 2.5? Yeah, this is at negative 2.66 repeating. So I now have my y-intercept, and I can write my equation in slope-intercept form. Y equals mx plus b is how I want it. So my m was 1/3, so y equals 1 over 3. X plus b, my b was negative 2.66 repeating. So this is my answer here. Check it with my work, please. All right, example 5, this is actually what we practiced yesterday. It says, what's the constant rate of the following graph? So what I'm going to be doing is looking for any point on the graph and finding my y and my x. So my constant rate, or my m, equals y divided by x. So in this case, it's going to be 3, because this is my y, divided by 4, because this is my x. So this is the constant rate of this graph, 3/4. You could also write this as a decimal, 0.75. Okay? And then we're going to look at this table, and we're going to find the constant rate of this table. Well, we do y divided by x. So I'm going to do y divided by x, 3/5. Okay? 3/5 is the same as 3 divided by 5. And this equals 0.6. So which one has the greater rate? The graph, which was 0.75, or the table, which was 0.6? Well, I'm going to say that my graph had the greater rate. And the reason being is that it was 0.75, where my table was only 0.6. And you could fill in a 0 if you want. 6 is 0. 75 is bigger than 60. All right, for this example, please find your constant rate by doing y divided by x for your graph right here. And please find your constant rate by doing y divided by x for your table. And then tell me what has the greater rate, the graph or the table. Okay. All right, for this graph, I can see that my y is at 1 and my x is at 5. So it's going to be 1/5. If I turn this into a decimal, just because it's easier to compare that way, 1 divided by 5 is 0.2. Okay? And then for this table over here, I'm going to be doing the same thing, y divided by x. So 3 divided by 14. And when I do this, it comes out to 0.214. Very long number. I'm just going to round off to 0.21. Well, I want to compare these, so I'm going to make my other number have a 0 at the end. So what is a greater rate, 0.20 or 0.21? I would say it is 0.21. So what has the greater rate, the graph or the table? The table does. Okay, 0.21 is greater than 0.20. Hopefully you got this correct. All right, I believe this is our last exercise and example for today. It says Jimmy runs 5 miles in 55 minutes. What's his constant speed? Well, the first thing we need to do is identify our x and y, our independent and dependent variables. Remember, the independent variables are always time. They don't depend on anything else. So I would say my x is this because 55 minutes is time. And then my y is this distance, my miles. Okay? So I've identified x and y. Now for the step 2, I'm going to do what is y divided by x. So y over x for my constant rate is going to be 5 over 55. And I'm going to actually just turn this into a decimal to find my constant rate. So 5 divided by 55. If I did 5 over 55, same as 5 divided by 55, and I get 0.09 repeating. So this is my constant rate. Well, what does that mean? That means in 1 minute, he runs 0.09 miles. So my constant rate, or my m, is 0.09 repeating. And what does this mean? He runs 0.09 miles per minute. All right. Step 2, or part 2, says Derek runs 6 miles in 60 minutes. Is he faster or slower? Well, we have to find his constant rate. So we have to do y divided by x for Jimmy. Remember that x is our time and y is going to be our miles. So this is going to be 6 over 60. Well, if I do this in a calculator, 6 divided by 60 comes out to 0.1. So his slope, or his constant rate, is 0.1. And remember that there can be an invisible 0 after that if it helps you compare. Well, he runs 0.10 miles per minute. So who's faster, Jimmy or Derek? Well, Jimmy is 0.09 miles per minute. Jimmy is 0.10. So Jimmy is faster. Oh, sorry, Derek is faster. I'm mixing up these guys' names. Okay. All right, for your exercise 6, please identify your x and y variables in this equation. Do y divided by x, find the constant. Do the same here, and tell me which one of these is a faster skater. All right, my seconds here is my x because that is time. My 3 laps is my y. So I have y divided by x. 3 divided by 47. When I do this in my calculator, it becomes 0.063. I'm just going to round it off there. So that is the constant rate, 0.063. Okay? On the bottom, I'm doing the same thing, identifying my x and my y. Remember, x is always time, so y divided by x, 5 divided by 62. And if I do this in my calculator, I get an answer of 0.08. It kind of rounds to 0.081. Which one of these numbers is bigger? Which one of these rates is bigger? 0.081 or 0.063? What's the bigger number, 8 or 6? Definitely 8, right? So this person, this is what? What's this person's name? Tina? Tina has the faster rate. All right, and we are done with this.